It's my great pleasure to introduce Dr. Santiago Schnell. He was born in Caracas, Venezuela, and did his undergraduate training in Venezuela, then went to University of Oxford, where he obtained a PhD. He did two postdoctoral fellowships and then began his academic career at Indiana University, went to University of Michigan, and then got out of the Big Ten, went to the University of Notre Dame. He's currently the William K. Warren Foundation Dean of the College of Science at Notre Dame. He's a professor of biological science and also of applied and computational mathematics and statistics. He does mathematical modeling that looks at enzymatics and really has pioneering research in quantitative understanding of enzyme-catalyzed reactions. Notably, he has the formulation of the Schnell-Mendoza equation, a streamlined method for determining the physical constants of enzymes in both basic science and clinical laboratories. So you may be wondering what he's going to talk about. I met Dr. Schnell when I have children at Notre Dame in his role as the dean, not because they're in trouble, but at Junior Parents Weekend, and we got into a side conversation about different things. They said, I teach a course at Notre Dame, one credit course on failure. And I thought, what better audience to hear about failure than a group of spine surgeons, right? This is perfect for us. So I'm very excited to hear what he has to say. So without further ado, Dr. Santiago Schnell.
Well, thank you. So it's a pleasure to be here. Let me tell you, so for me, this is very intimidating. So speaking to failure is never easy, so it makes you feel like a loser most of the time. But what I want to talk first is about the common ideas about failure. And we have this set of common ideas about failure. Let me see if the slides are coming in. They're there. So Churchill, assume to be Churchill, they say success is learning to fail again and again with no lack of enthusiasm. It's not proof that Churchill said those words, but they sound great if they come from Churchill's mouth. We have one that we know that comes from Thomas Edison. So I discovered 100,000 or 10,000 ways of actually failing. And somehow things didn't work until I discovered the light, which is a really great thing. Or if you go to the biotech industry, you're going to be hearing all the time, fail fast, fail often. But that's not the kind of failure that we should cultivate neither in medicine nor in science. And let me tell you why. It's because in those phrases, failure is considered born as powerful and sustaining a success. And the reality is that failure is not sustaining a success. It's a completely different thing. And let me tell you, if I would say to my mother that I got invited to give a talk to a group of highly accomplished physicians, nurses, and medical students about failure, she would tell you, I'm perfectly qualified. And let me tell you why. So this is the stage. So first, I'm a scientist, I'm a parenting scientist, we do that, but my mother will tell you the following thing. From all her kids, the only one who never had the courage of actually getting a real job and leaving academia is his son. And you see that I'm a failure to launch. Who better person qualified to tell you something about failure than somebody that is in his mid-50s, and if he goes to the job market, he's going to be unemployed, unless he goes to another university and decides to study. But at the same time, I want to tell you why failure is important for us in the ivory tower, those that we cannot be employed except in universities. It's important because for us, it's an art form. Believe me, we thrive on it. So for 1,000 years, academic institutions have been thriving on failure. People who study rhetoric, which is one of the first academic disciplines ever taught in an academic institution, how you are a better speaker. You fail once, you improve the speech again. You failed a second time, you improve the speech again. And then you come with the tricks of rhetorics. The same thing with poetics. What are the points that are going to move the heart and the minds of people? And the people who were studying politics for many years were failing. And then suddenly we became the scientists. And for the last 400 years, as well, we have been failing successfully. And one of the things that drives us in academia is this phrase like Samuel Beckett: ever tried, ever failed, no matter, try again, fail better. For us, it's an art form, and it's an art form in the same way that scientists make discoveries. You probably remember the discovery of penicillin. It's an accident in the laboratory. Somebody with their sandwich ruined the Petri dish. And suddenly there was a discovery that in the sandwich was mold. And that mold had a molecule that was able to destroy the bacteria. And how we do that is by failing again and failing better, learning from those failures. But one thing that is important is that for us, this history of failure allows to be as part of the shoulder of giants. You're going to see that this is based on a class that I teach. It's in a book that as well with other students, and we're using a lot of people that are very important, have been thinking very seriously about the subject of failure. And Benjamin Franklin, he said that perhaps the history of errors, of failures, is more valuable and interesting than the history of discoveries. Because once you discover and you have a fact set in place, facts are incredibly boring. There's no fun on them. While the errors allow you to discover new facts. And that's what we actually try to thrive on. And let me tell you, failure is so important that nature actually thrives on it. So this is the family cat. My wife and I, we find ourselves with our children. They have their professional lives or waiting for our grandchildren. In the meanwhile, we got ourselves a cat. And the cat goes into the garden. And then it tries to catch the squirrels, the birds, the little mice. And my wife thinks that the cat is a fool and incredibly silly because it's unable to catch their prey most of the time. The reality is that we know in science that statistically, preys are incredibly ineffective to actually catch their food. In fact, less than a quarter of the time, animals are able to feed themselves when they try to catch an animal. And that's what my force successfully does. So he's a pretty successful animal when you compare it on average. But the other thing that nature as well has is that when you think about evolution and how life has arrived, has been a history of failures, one after the other one. Mutation, animal doesn't adapt, or plant doesn't adapt, they get extinct. And if you think about all the species that have existed, most of them are extinct and they have been failed. Only the ones that remain here, at the moment, they're not a failure. So, and that's the way that we try to operate in the natural sciences. But I want to bring a very wise philosopher into the table. So you probably remember this phrase that he was. So Donald Rumsfeld, he was incredibly mocked for a number of years. And what I want to focus you. So he says we know there is knows that are known, and there are things that actually we know very well. There are also things that we know we don't know. And those are the major scientific questions that we're going to be thriving. Or there are the things that we would like to find out. But this is where people actually were laughing. And in fact, it's probably one of the most wisest things politicians have said in a number of years. Unknowns, the ones that we don't know. And those are the ones that actually scientists, they thrive on. Is where we didn't have an idea that the problem existed, but suddenly in the moment we discovered it, we start to make further inquiries and try to be successful. Now you might be wondering, so what are the scales of successes? And what is the relationship between success and discovery? Let me tell you the following thing. So if you look into the gradient of failures, a debacle is probably the worst failure that you can imagine. And in fact, if you go to Google, you type debacle, and then say meaning or etymology, you will see that window popping in. And it says, a sudden ignominious failure, a fiasco. It's a disaster. But if you look at the origin of the word is very, very illuminating. It actually comes from the French. And in the 19th century in France, when people were talking about a debacle, they were actually saying there was a piece of ice that was breaking apart from the block of ice and was moving down into the river. It was a landslide that was actually happening. It was something that was breaking down and opening a new path. And if you think very carefully, there is an equivalent award in English that was invented relatively recently, breakthrough. It actually was invented as a product of the war when the soldiers were able to actually break the barriers and go through. And the correlation between the words of the failures and the words that we use now for discovery, they actually have the same etymological origin. So when we try to fail and we want to try to fail big, it's because we're aiming to make a breakthrough and a new discovery. Now you tell me, well, Santiago, that's in the average tower of academia, and maybe your mom is right, you might be a big loser, because in medicine, we cannot afford actually failure. Failure in the clinic. So, and here I'm going just to quote Sir William Osler, who is one of the 4 professors that founded Johns Hopkins University. And he said, medicine is the science of uncertainty and the art of probability. That's part of what you're doing all the time in medicine. But let me give you some examples of actually, so I think I went too fast, of what are the things that you do in the clinic to avoid failure, controlling the knowns that are known in the clinic. One thing that you do every day in the clinic, which is very important, is communicating effectively with the patient so that the expectations are met. And I used to teach in the medical school at the University of Michigan, and one thing that when we're teaching quantitative reasoning to physicians, we will tell them, avoid percentages. Percentages are very confusing, even to very intelligent people. So if you say to somebody, the surgical procedure has 95% success rate, people are going to come with the impression to be fine. 95%, well, 5% of me is going to be okay, but 95% is going to be fine. But in reality, that's not what it means. What it means is that 1 in 20 people actually are going to be a disaster. They're going to be a complete failure. When you communicate effectively with your patients, you actually have the right expectations and you avoid to be a failure. The other thing is that, for example, clinics, they have the morbidity and the mortality meetings. And these are weekly reviews, typically, where you discuss what were the compliance issues that you have, why a patient wasn't treated in the appropriate manner, why there was this specific failure. And then corrections are done through the process to make sure that they never happen again. Those are controlling the knowns that are known. But what about the ones that are more extreme? And let me just move to one that you're going to find really exciting. So this is called inside the Hawthorne effect. What would happen to me if I know that the person who taught me to be a public speaker would be watching me on my back to make sure that if I'm doing a good work? I'm going to be doing probably a really great work because I know that this person is going to then, after I finish the talk, tell me you did this well, and so on. There was an interesting experiment published by Barnett et al. In 2017. It's called what is called a natural experiment. They went retroactively and did a meta-analysis of what happens when the Joint Commission goes to hospitals and with the mortality rate of the patients. An interesting thing. So it's a good idea to go to the hospital when the Joint Commission is going around. Because actually what you see is that the mortality rate on average when you go to the hospital in a day where the Joint Commission is not in is 7.21%. But in the moment the Joint Commission is in there, watching the eyes of everyone, go Jay, start to run around, the mortality rate goes down by 1.18%, which is, this 0.18% is significant. When you count the number of individuals saved, it's a significant matter. What happens on the major clinical facilities like, the University of Michigan Medical School where I used to work for many, many years? That effect is even bigger. So you start to say that the mortality rate goes from 6.41 on a regular day, and then it goes down to 5.93 in the moment the Joint Commission is around. So you know now how you can be protected if you are a patient and not a physician in a given time point. Knowing that you have this Hawthorne effect helps to control the known unknowns. But what about the most difficult thing? So what we can do to discover the unknowns that are unknown in medicine? And I'm going to tell you a little bit about what I do for research. Just 1 second. My research program departs from one very basic principle. We're healthy until we're diagnosed that we're sick, we have a disease. However, there is always a continuous between health and disease. And my research group is trying to figure out how we can measure that continues. We come with mathematical equations, software tools, specific approaches that you can apply into the clinical setting or in the basic science to discover that transition. This field is a field of metrology. We are trying to measure things. An interesting metrology is very similar as a scientific discipline as medicine because we have standards and we want to hold them, and we don't want to break things because we want to make sure that the measurements are done in the right way. I'm a member of an international commission that's called the Standards for Reporting Enzymology Data. Enzymes are very important. PCR is an enzymatic reaction. We use it on a daily basis in the clinic. We use many other enzymatic reactions for understanding in the basic laboratory fundamental signaling pathways and metabolic pathways that allow us to understand better organisms and the human beings. But the problem is that it's very difficult to make those measurements. When you ask two independent laboratories whether you can replicate their data, you will find that the replication rate is very, very low. In fact, there tends to be an error of 100, of 100 of order of magnitude, which is 100 times. It's significant, telling you that the constant of the affinity with the enzyme is 1 on 100 and 1 on 999, which is 100 in the terms of the order of magnitude, is massive. It's a big error that we cannot afford to commit. And what we do is that we are a small commission, or just of a handful of individuals, so no more than a dozen, that we meet every year to discuss the best practices. What are the failures that we're committing, and how we can improve upon those failures to make sure that the measurements are done more effectively. And sometimes what we find out, when I report one of my failures, we discover an unknown that we start to do new sites. When there's a community in medicine that actually does something very similar, they work very hard to work on the unknown unknowns. And this is the orbital surgery community. They establish a commission of 40 that they have the world-recognized surgeons that they meet once per year, closed door. And they have to make the following commitment. You come to the meeting and you're going to be present one debug that you have that year. One that you feel really embarrassed about. Maybe 2 or 3. And what you do is that while you're presenting those, you're interrogated very deeply. They could tell you it was a failure of diagnosis, it was a failure of the technique, or the treatment. It's a personal failure. Did you operate that person during your birthday? Which is a no in most of the cases. Or it's a professional one. There was something that wasn't working in your facility at the time, that you didn't have the right support. And then they would ask you, could you have done things differently? Should I have done this? So why I was chosen to decide to use that procedure? And then if the questions are not answered properly, then I start to think systematically, do we need a new technique? Do we need to go back and work with the basic scientists that are doing the surgery and start to figure out if there is a new technique or technology that we need to approach? Or even the worst questions, was necessary to actually treat this patient? Would have been the outcome better if the patient would have been operated at all? These are the things that the commission comes in. And interestingly, their commitment for the community is that after that meeting, they publish better standards, that they are shared among the community. They publish better papers and better techniques that they are shared with the community, and they help them to become better. And that's like the whole lesson. It's not to castigate yourself. In the Strength Commission, we don't castigate ourselves for failures in the same way with this small community that the orbital surgery community they have. And what the take-home message in here is that in disciplines that they are highly standardized, like medicine or measurement science, what you have to do is that you need to live with failure. And failure, in the case of Henry John Newman, that is a recent Catholic saying, he would say that to live is to change, and to be perfected, which is one of the goals that you will attempt to do as a physician, and is one of the goals that I attempt to do as a measurement scientist. To have that perfect measurement, to have the perfect outcome, you have always to be ever changing. Thank you.